Go ahead.
Good day, everybody. So, okay, who do I have in the class participating this evening? I have Mr. Lu, Mr. Derek.
Yes, sir.
Right? Okay. Okay, Ms. Funke cannot join again today. Basically, for the next 1 hour before I hand over to Mr. Dozier, we'll run through the concepts we introduced yesterday. So, and the essence of this particular class is to introduce you to data processing. And we expect you to be able to use pandas to do a lot of data processing in Python that you can do in SQL. So we need you to have a grasp of data structure, data process, tables, rows, and columns. As you did it in SQL, you should be able to do it with Python. One tool for that is pandas. So, and we're trying to introduce now. In addition to pandas, which is a data library, there are some other modules that help you to work around your data. So from time to time, you have to make use of the modules. These modules, some of them have been written by other developers, other agents, other body. So an example of them is the first statement in this line, which is import OS. So in general, if you want to bring up a module into your own space, you use the import statement. Now you can write your own module as well. You can write your module and import it in. So, but for this class, we'll not be writing any external module, but we'll be making use of some of these modules. So you will see this import from time to time. It was introduced yesterday. Now you can do import with an alias. You can see this in this particular highlighted. You can give an alias to a particular library or module when you import it. Now you can import specific objects from a module, as that was illustrated in the example while we dealt with datetime, the datetime module. And we saw that inside the datetime module, there is a datetime object, because there are several objects in the datetime module. There is a time object, there is a datetime object, there is a date object. So from time to time, maybe it's only a particular object that you need in the entire module. So the module here is the datetime module. But invariably, there's another datetime. So it's just by coincidence that we have the same name. You can have date from datetime, you can have time from datetime, and you can have datetime. Now, the datetime object consists of date and time together. The date object is just the date, like we have in this example. You understand? We also have another example, NumPy. NumPy is a mathematical routine. You use it to perform various mathematical functions, from your logic, your logarithm, your sine and cosine. And you can say from NumPy, you can import just randomizing numbers is a basic mathematical concept that is very useful in Python programming. So we'll run this again. Now, I gave an assignment. Should we run through that again? Mr. Lu or Mr. Derek, what was the assignment again? Let us run through that and start with it. Waiting for your response.
The assignment, I didn't know. Is it the one we have on the Google Doc?
No. The assignment of yesterday, not the sequel. There was an assignment from yesterday, Mr. Okay, is that Mr. Olu talking?
Yes.
Okay, what of Mr. Derek? Did you attempt the assignment? Okay, obviously no.
I didn't
So,
attend the assignment.
so we employ you again. It's important. It's very important you deal with the assignment. So I was testing a particular knowledge set. So if you attended the assignment, yeah, quite you have a busy schedule or something, but if you have spent like 1 hour to go through some of those things, just try them. But today, at least you have the recording, and whatever assignment we have today, please let's do it. So we'll start again and run you through the class. We'll be spending like 40 minutes or so. The OS module help you to do a lot of operating system matters. So dealing with operating system means your Windows, your Mac, your Linux. What are the things that you do on your system? You open files, you delete file, you create file. Those are operating system routines. So the OS help you to do that. You find a directory, you list content of a directory. That's operating system in general. So the module is just say import OS. So if you import OS, now you can do something in the OS. One function inside that OS module is get current working directory. Get current working directory. That's the function. So if you do that, it tells you the directory where this thing is running. And we have that directory or folder, as we call it in Windows. So you can see the folder name. So the general name in operating system is directory. So which is common to Linux, Mac, even Windows is directory, but we have a simpler collocation for that, which is a folder. So you see our folder here. That's where we're working. Now I can change this, but I don't want to complicate the issue. We can change the directory. So there is another OS command for changing directory. And we can write a file. That will be illustrated. We can list the files in the directory. So if we want to list file in a certain directory, let us introduce another line here. So list the files in the current directory. Now you can specify any directory actually. List files in current directory. So again here, I can say current directory is equals to os dot get current working directory. Now, if we print that out, we can say we have the current directory as a variable. I just want to test that out. Okay, which is true. Now, instead of printing out, it's not as if we want to print out the current directory. We want to see the files inside it. So the function for doing that is list directory. So it's os.list directory. In Linux, it is dir, no, it is ls. ls, I think, yeah, ls in Linux, and maybe Mac in Windows, if you just type dir, it lists everything. So it's that same idiom that gives rise to this in Python. So the function is list directory and is descriptive enough. So we're passing the argument. If we don't pass the argument, let me test. Suppose we don't pass the argument, what do we have? Okay. So if we don't pass the argument, which is current directory, it picks the current directory by default. But you can always pass an argument in case it is not the current directory you want to run. Incidentally, we have the same thing, current directory. So it takes an argument, which is the folder you want to list. Now you can see what we have there. Now, if we don't want to, if you don't want to list the current directory, that's everything we have in this directory. You can see them. So if I don't pass in this argument, it will still look for the current directory and run whatever it can find. So you can see what we have from that list. It's very interesting that you can list the file. So this current directory, users, Obdion, downloads, class, and so on and so forth here. Suppose that's current directory. We want to get the parent. We should be able to get the parent folder. This required lessons is inside the folder called Python. So if we want to get the parent folder, there's another function we can use to do this. So I want to keep this listing directory commented for the moment. So now I can say the parent directory is equals to, excuse me. So the parent directory is os dot path should give us the parents os dot path dot path dot directory name of, as a function of the current directory. So let's print what's inside parent. Print what's inside parent. And okay, something is wrong there. Print B. No, something. Okay, I'll run that again. So now can you see what I'm talking about? So the parent of this folder is this guy. Now let's check what is inside the parent instead of the current directory. So I'll now pass in parent here. I'll pass in parent here. So what are the things? So you can transverse a directory like that. You can say, okay, we have a number of things here. So we can do this thing recursively and say parent2 is equals to, so that means we are going back by another step, os.path.directory name, that is folder name of parent, the first parent. So the second degree parent now, or grandparent. So it was a grandparent of that folder. Grandparent folder. So instead of listing the parent, let's see what we have inside grandparent. Grandparent. So we run this. See what's happening here. The grandparent is now class test. In the class test, we have this file, Store. We have a folder name Python, we have an Office MS, we have SQL. So you can do a lot of things dealing with systems in general. OS can do a lot of things, and I would like you to deal with that. I want us to move quickly and open and close a file. Like I said yesterday, opening and closing a file. There are 3 modes of opening a file, and it depends on what you want to do. If you want to read, you open for reading. So the string code for that is R. So you will say open, the file name will be specified. The second thing that will be specified is the mode. The mode is a single character, R, the W, or A, single character. If you put R, you want to read it. If you put W, you are writing. If you put R, you are appending. Now, appending is writing, except that it will not overwrite what you put there. It will not overwrite. So let us try and see. You know, yesterday when we were writing, we added the new line character here, so that we can have all our items written on a separate line. So let us run this through. Let's run this. You see the output? So go back there, run this, run this. So you see the output. Now, but let's do, let's add something here quickly that we can use. Mr. Derek, I want us to add something here.
Yes, sir. Hi. Sorry, I just came back came back to class. I was out for
We just started.
a second. Okay.
We just started. What you missed is some of the maneuverings around file system. We missed that, but I'm now dealing with reading and writing file. So I'll talk about that quickly. Reading, writing, append. So we're demonstrating writing to a file here. And I'm using the same example that we went through yesterday. But I want us to introduce something here, because we will use that data later in this class. So yesterday, we did something. We tried to build a CSV table with the element of opening and closing a file. So we have ID, first name, last name, gender. Let us add something here before the end of line. Let us add another column. And the column I want us to add is date of birth. Date of birth. So that means after gender, we have to add date of birth for each. After the gender, date of birth, after gender, date of birth. So we can put arbitrary dates. And just and we're going to use what do we use? Month, day, year, or day, month, year. Okay, let's do year. You see, the format of the date is important. Okay, there was a date example we did yesterday, right? Which format did we use? Which format did we use yesterday, Mr. Olu? I was looking at scrolling down the date example we did yesterday. Okay, we did a year, month, day. Year, month, day. You know, the date can be very tricky.
Yeah.
If you are not consistent and deliberate about the format, you can have a problem. So many systems, they don't accept certain forms of date. Now, so far from experience, the most compatible date format is the year, month, day. Almost universally, the majority of the system from SQL to Python and a lot of data science to at least they agree with year, month, day. But if you do day, month, year, that's where you have confusion depending on the locale. The US is actually month, day, year. UK is day, month, year. So there could be kind of conflict depending on the locale. So if you use the year, month, day, it's like locale agnostic, depending whatever the locale, year, month, day will always be received. So we're using year, month, day, yeah. So this one I can say 1980, January 22. So this one, let's say 1981. Apologies, I'm just putting arbitrary date. 09. And this one just put 1982. 1982, September 10. So let's run this quickly. So we have our output. Then let us read. We want to read that our data system now with pandas. So I will just go down. So you can see now. Let us do a little more with this panda. We'll do a little more here. So I'll just emphasize some of the things we checked yesterday. But I want to show us a little more about pandas here. See these other examples. The essence of this topic here is reading pandas data. That's what we're actually doing here. So you always import the data library and the alias is PD. You can read CSV. This is the syntax. Please note the syntax. You can read a TSV file. You can read an XLX, that's Excel. And you know we have two types of Excel. Excel, I think it's 2007 and above is the XLSX. That's the modern format anyway. So it's supported again. And you can read from SQL. You can read SQL as well. That's another mode. So since we just have our CSV example here, we are reading from CSV. So, and after reading it, we have, but look at our first name is string. Even our ID is quoted is string, last name string, everything is string. The date is string. So this date is a string at the moment. It's not just a date type. So let us do a little pandas data manipulations there. For instance, you can check a little analysis. Let's do a little data analysis of Python. So if you want to check, unfortunately, we have only three. We have three data items. Let's do something here. I want more data, but maybe. So I'm going to put append and run this twice. So append will keep running to overwrite. So I run it again. So let us do the pandas again. Do we have more data? Yeah, we have more data. Now there are repetitions here. Repetitions here. So it's good. You can use it for a little cleanup, except I wouldn't like this. I don't like that. I don't like that. It's okay. It's okay. Let leave it. The data is dirty, but you should be able to do some things about it. So we'll turn that dirt to advantage in a moment. Let's just perform some analysis on that. Now, if you want to do, let us perform summary analysis on this data. We have our data frame is df here now. So here we can do df dot add. So the df dot add function, it will just show you a snapshot of the file. Now understand that this is just a little. You'll be having millions of records. So we're just having 10 here, for example. You have millions of records. So if you want to do a quick look through, you say .add, but you can pass an argument to add if you don't want the default. The default is 5 rows. So you can say, okay, show 3. And you can say you want more than 3. You can say show 8. So depending on what you want to see. So the default is 5. We want to quickly see what is inside. That's that about that kind of summary. Now we have that. Now let's we saw some things yesterday that are like slicing of the data, like dealing with column name. Let's have an analysis here. I want us to remove some of this data. That's the first thing I want us to do. Like, look at the full data here. This one, after the initial header, we should not be having this line. It should not be there, right? This line, it should not be there, right? So we'll remove them. That's the first thing I want us to do. Then after removing that, I want us to convert this date, which is a string, to proper date. Then let us do some sorting. And that will be the end of my contribution to this class before I hand over to Mr. Duze. So I want you to follow me carefully. What I want us to do with this data, number one, let us do a little data cleanup here in pandas. So luckily our dirty data comes handy. We're going to clean up this line. This line doesn't make sense. It should not be there. So each time you are dealing with data, you may have to do cleanup. And how do you know you will clean up? You first of all check what is inside the data. So one method of doing that is the df.add. But in a million record, checking the first 5 rows may not be the all. So you may check the tail as well. So you say df dot tail. So Mr. Olu, what would tail do if df dot head show first 5 line?
Please, can you ask that question again?
Okay, we can see that df dot head is showing first 5 line. So df dot tail.
df dot tail will show the last 5 lines too.
Yes. And if you want specific, you can pass in your parameter. You can say show 3. So you can see it's showing 6 to 10. You can see there. Then there is another function again. You want to know how many rows, how many columns. How many rows, how many columns. So let me do another line to do that. So shape, the shape of that object, that data frame object, you say df dot shape. So df dot shape. So if you run that, it tells you we have okay. Sorry about that. Shape is an attribute, it's not a function. So I shouldn't put the function bracket. So it's telling you that we have 11 rows. It's actually 11 because it's 0 to 10. It said we have 11 rows, 5 columns. That is that. Now you can transpose this thing like a matrix. It's actually a matrix in reality. So you can do df. You can say dft, transpose of a data frame is equals to df dot. You need to be careful. If you are reassigning your df, you may destroy your object. So most time when you are dealing with data frame, it's better you assign to a different object. So if I say df is df, I will lose my original object. So I'll say dft is df dot t transpose. The transpose function. So let's see what is in dft. Yeah. Run that. You can see this, how powerful this thing is. All of a sudden, first name, last name, gender that were at the top is now, it has become what? Yeah.
ID.
It has become ID. Now, this has become column. The rows has become column. Very powerful. Now, there's something in Excel that looks like this. Who knows it? Is anybody familiar with Excel with?
Is it a lookup or something?
Is pivot.
Sure.
Pivot tables in Excel. You can do with a pivot, you can do a lot of things. One of the things you can do there is transpose. So you can transpose in Excel like a matrix. It's the transpose of a matrix in mathematics. Let's do maybe 2 more analysis. Everything we are doing here is just summary analysis on the data. You've not started cleaning up actually, but if you want to clean up the data, or you want to make meaning from the data, or you perform some data science analytics, you have to even see what type of data. That's what we're just doing here. Without going through, let's say, millions of records, we want to see a little. That's what we're doing. So let's create this. Let us have, can we list the columns? Let's just list the columns of this particular DF object. So to list the column, we just say, you know, our DFT was used. We still have our original DF touched. So to list the column, we use the column attribute, we say df dot columns. df dot columns. So if we run this like this, can you see something? So all the columns here is listed, supported by the type of the object as well. Now I want us to check something. Can we check each I'll come back here again. I just want to see df dot edge again. I want to see df dot edge of just 3. 3 will do for us. Okay, look at this data now. I want to know what data type is each of these columns. Check data type for each of these columns. Check data type is each of these columns. The first thing we can do, we can bring out just one of the column. We can bring out one. So we can say df of 1. We do this. No, iloc dot iloc of 1. I can mention the name. See, with iloc of 1, we have okay, there's a noise there. We have a background noise. Mr. Oli.
I'm sorry.
So iloc of 1, see what we have here. It's giving us the first row, but we want to slice a particular object here. Let us pass in the column name here. So we say df of the name of the column. Let's use the date of birth. DOB. What's there? What's wrong? What's wrong there? Oh. Okay, let's use lock. The lock is but you can run it. Something was wrong there. You can run it explicitly actually. Even lock is not working. I hope.
Since you might need to include the quotes.
You said?
So I think you need to include the quotes.
So remove.
No, include.
Okay, the double quote, right?
Yes.
Yes, I'm suspecting that. Okay, so the single quote will be inside the double quote. Is it like this? Yeah, Mr. Dose.
Yes, that was what this is what I meant.
But it's not working too. There's something wrong with that.
Move the lock.
Okay.
Yeah.
DOB. With DOB quoted. Let me check something. Let me check something. It is saying there's a key error. This should go.
So just try printing just the column names because since the way the names are, that's the help of
Okay, okay. We printed the column name here.
yeah.
Okay, I think it's escaped. It's escaped. This.
There's some spaces in the
Let me write that data. Let me write the data. Let's just write the data. So space. Somehow this space is, I don't know why. We just rewrite the data. Let's do W to overwrite. Then we append. Okay. Let's check the column here. Okay. I have to load. Load it. Let's check the column. There's still double here. The space for date of birth. Okay, but one thing I can see here, there is a double. Okay, let us deal with first name first. First name. There should be one. Okay, so one, that somehow, that one of the quotes is part of the name. That's why it's doing double quote. One of the quotes here, so single quote inside. But this DOB still has problem. Let's check writing the data again. That space is a confusion. So I don't know how are we getting that.
Yeah, I think we need to remove the single quotes and this space in between the commas.
This one?
Yes. And the single quotes.
Single quotes for the heading.
Yes.
That's true. That's true. That's true. Okay. That's true. So let's use W to clean up, and then we append. So we load it here. Oh, so the header is clean now. The header is clean. And the column name. Okay, instead of having that double quote, let's go. Def 3. So df dot first name. We can remove this in our quote now. Okay, good. So let's deal with the date of birth. So we see the date of birth. Now, can we get the type for each? I want to get the data type. So we'll say for this particular column, let us let's do another line. So we can say df of the date of birth can be single quote actually, or double quote. So, but we want to find the type, D types. So, what do we have there? Say D type of 0. It's not giving us something. It's not giving us something. By saying the type is objects. Okay, now the entire DF itself, let's find types for the entire DF object. So it's saying ID is an object, first name is an object, last name, everything is an object. It's an object. So the reason why it is an object is that it is complex. So, but there's a way to check type of object further. We can check if it is a string. You can check if it is numeric. If it is numeric. I think we need a further cleanup in our data up here. We need a further cleanup here. We can remove these quotes too, so that we have pure string there. It's already quoted. So we have proper comma separation. So we have comma separated values. That's so we expect some integer. Comma separated. But anything it sits between the comma is data. I remove this. Remove all the quotes. This. So we'll do the right first to clean up what we have there. So we turn it to append. This. Okay. Let's load. Okay, we eliminated those things. So let's do the normal column name. Let's do the date of birth. We now be without quote. So it's a proper string now with unnecessary quote. So the object types. So everything is still object here. We still have object. Now, can we remove all these DOPs? Want to remove, want to filter. Want to filter by a particular column value. So let us come here. So let's say DF2 we say DF2 is equals to the original DF with these conditions. The original DF filter by this condition. So you pass in your filtering condition. So the condition now is that one particular column, and the column is DF of date of birth. That's the column we showed here. This entire column, this DF of date of birth, this entire guy is the one we are dealing with. So you specify it inside this main bracket. So DF conditions. So the condition is what we want to specify. So the condition is this column. This column must be equal to must be equal to what? Must be equal to DOB. The DOB as a string. DOB. So I think we need to invert that rule, but let's run that as C. Did you get something? Okay, so let's print DF2. Run this again. No. Okay, I press capital. I press caps lock. So let's bring DF2. So it's showing where it is. So what we need is where it is not, because we want to filter all these ones away. So where it is not. So I think it is safe to even replace the original data here with DF. We don't need the wrong thing. So this is the proper DF. So instead of DF2, it's not a good practice to always overwrite, but we should overwrite here because we are taking away wrong data. So by the time you see that it's cleaned up. We have removed that junk. Can you see? We remove the junk. So we have a cleaner data here. So that's the first assignment. So let's call this one clean up some data. Okay. So let's do something again. We have a cleaner data there. So with a clean data, can we perform something? Let us add additional column. Can we get year of this date of birth? Can we get year? So the first thing is that date still a real date? We'll find out. If we try and perform a year function on it and it fails, that means we have to convert the date. But I don't know if it is explicitly converted already because it is clean. So we're going to do something again here and say you can add an extra column, you can remove column, but let's even see. Let us just deal with column and say df of another column. Sorry, it should be square. So let's call it year. The column is a year of birth, year of birth, which will be derived from date of birth. So we say this one is equals to, we're going to use pandas date time index. If it doesn't work, then we have to convert first. Pandas dot date time. The function is date time index. The index of the date time. So there are a number of methods of carrying this out actually. So one of it is using the date time index. You can find other methods. You can have you can convert string to time. So I think we should do the string to time because I believe that guy is the string. So we can do pandas itself. The object itself. The object itself is df of dob. Df of dob. Dob. That's the name of the column. So I need to quote this yob. Yob. So we're going to take a break and after this, and when we are back, Mr. Doze is taking over. So, okay. I would like to, I don't want to, okay, let's run this thing and see. Let's just run it and see. Something is wrong there. What's it saying? It's trying to say we should use iLog.
It's just a warning. Right.
Mr. Doze?
Yeah, I said it's just a warning, but I think it works.
Okay.
The assignment works.
Let's now check what's inside here. Let's check what's inside here. Sorry. Okay. So, okay, it just added the column right now. Let's do our conversion here. And let me show. So we're going to do dot date time dot string to time. That is if it's a date and it can convert well. But with the year, month, date, I believe we should go string to time. We want the year. So you remember our time string, percent Y for year. Okay, let's run this. Oh, so what's the issue? Now, you can only use this date object with date time. So the first problem we have is that this guy is not a date. It is not a date. So the first thing we need to do here is, before we even go further, is to convert that date to time. That string, convert date string to date. We need to do that first. So we cannot proceed. It's not known as a DT. So we are going to have something like a conversion. So let's just do df of name of the column. Let's call it DOB2. I don't want us to destroy that column yet. So DOB2, we can replace it, but let me be sure we got it right before we replace. So we're going to do an explicit conversion using conversion object. Pandas dot to date time. So there's a function called to date time. Date time. We are converting that column to date time. So which column are we converting? We're going to pass that column that we are converting. Then we're going to specify the format. So the column we are converting is this guy. This guy. DF date of birth. It's a string. It's an ordinary string. We'll pass it in here. But we're going to tell pandas the format. So we'll specify the format. I will say the format is equals to make it a date in the first place. So to specify the format, our format is a year. That's percent Y. Hyphen. The next thing is month. That's percent M. And then we have our day. Hyphen again. We have percent D. So luckily we simplify. We don't have hours, minutes, seconds, so we can just filter that off. So so that should be fine. Let us, before we proceed here, let us check what we have there and see if our conversion succeeds. So it looks like it succeeds. So let's try this out. Look like it succeeds. I just take this to another line. Okay, so we'll try this and check what's in DF. Okay, so we're now deriving our DYB from DOB2, which has been converted. Remember? So let's run this. What's happening? You can see it. It worked well, right? It worked well. So I will be so let's go back and just do a little cleanup. Our DF is already tampered with, so we can go back all the way and load. Let's load the Panda object afresh. So it's loaded. We really don't need all this in between, so we just want to reload. But after reload, we need to do our cleanup. Okay, we did the cleanup here. Let's do the cleanup. Okay, so we have our DOB. Now, instead of doing DOB2, we can explicitly clean up the DOB here. That is, the DOB that was a string will become a date. Now, after doing that, let us check this thing again, df.types. I think that df.type, instead of having an object, we should have a date afterwards. So we have our conversion here. Let's do a next line and check the types. Check the types. Okay. So we've not done this. Okay, now. So we are overwriting the DOB column. So that is the string will be replaced with the converted date type. So let's run. So we still have our DOB. You are still seeing the same thing. But to know that this object has changed, let's check the types. So, where are we? Okay. Now, you see, the output is now a date time. It's a date time now. And that's why this conversion can work. So the datetime object can be converted into year by picking the year element of the date string. So this function dt cannot work except this is a date object. So when we run this one now, pam. Okay, was there an error? Okay, there's no DOB2 again now. We have our DOB as the correct column. So, okay, with that warning, thanks, Mr. Dese. Okay, so you can see the Y, the year is 1980, 1981. So it's extracting the year. It's extracting the years. So you can extract months. You can extract date, depending on what you want to use. So you can say, we don't have sufficient data set here. But you may say, okay, those that were born before 1990. So we want to see those that were born in year 2000. Okay, let us have the Gen Z customers. The Gen Z customers will like iPhone. They will like Android. You can say, okay, the Gen X and the people that were born 1980 to 1990, they are more interested in family life. They want to buy PlayStations for children at home. We can do an analysis with this data and make sense from it in real time. I use it to classify the kind of adverts that must be shown on your Facebook, on your Twitter accounts, and so on and so forth. So you can write a Python program that does that. These are the elementary. So you format the date. Most likely you are given string. You format it to date. You have the year. So you can filter. Unfortunately, we have 1980, 1981, 1982 here, but we may not make too much sense from it. But let us do a little filter. We want to see those that were born in 1982 as crude as our data is. Let us say our DF3 is equals to DF with condition. With condition. What is the condition? The condition is when DF of a particular column, we're bringing up a particular column. And what's that? Let me do this thing in 2 stages. Let me do it in 2 stages. Just say print. Or I'll say, I just call it X for simplicity. X is equal to DF of a particular column. And that column is what? The column is the YOB. I want that column out. Run that. So what is X? Bam. So you see, you can see that list there. So it's a list actually. However, X is now our list. So we now have a subset of the data by filtering and say DF3 is equal to a filter DF, original DF. So how do we filter it? There's a condition. The condition is that this is our column called X. Now I can put X here and I can write the entire DF of YOB, but it's cleaner if you assign it to a variable. So X is what? X is equals to 1982. 1982. 1982. So now show DF3 afterwards. Let's run that. Okay, there's an issue. What's our problem? What's our problem? DF X. Okay, let's do it step by step. It's not seeing anything. It's not seeing anything. That's our X. Is an object. So that guy is an object. It's not based on. Is an object, so there's a problem. It's not directly equal to that 1982, so, and it's not a string. Let us try string and see whether it's a string. Let's quote it. Or we can convert to an integer. Wow, it works. So it's a string. You understand? This X is a string. And that's why I return it as an object. An object is even more general than a string. But a better thing we're supposed to have done here is this. Let me have, and that will be the last. We've passed our time. So we can convert X into another object. So we do now say, let me say Y is equals to converted X. Y is equals to X dot, convert it to int as type. int. So print y, let's see. Is it the same? Now, look at it here. It's not telling us that it's a 64-bit integer. Now, if I rewrite that original expression that did not work before I put quote, that is this guy, I'll just do a df4. Come here. So after this conversion, remember x is the string, so y is the converted guy. I will not put the quote. This is an integer now. It's an integer comparison. So just say df3. Run that. Now you can see that ordinary integer work because we converted this one to an integer. So let's take 5 minutes break. Our time is fast spent. You can note your questions. You can entertain that at the end of the class. When we come by 8:25, Mr. Doze will take the rest of the class. So thank you. We'll take 5 minutes break.
Thank you, sir.
Yes, sir.
Are you guys back? Mr. Olu, Mr. Derek, Mr. Francis? Are you guys back?
I'm here.
All right, Mr. Dozier, let's get started.
Okay. Okay. So let's continue from here. So here we have trying to build a data frame. We've seen how to build one from a file. Then can also build a data frame from a list and a dictionary. So here we have a list of names containing countries: United States, Australia, Japan, India, etc. And we have another list that contains drive rights, and then another that contains cars per car. So this list represents columns on our table. Yeah, columns on our table. And then when we want to define, say, a data frame from a dictionary, we know that if each list is a column on our table, then we build a dictionary. If you remember what a dictionary is, it looks something like this. Then is a key word, key value pair. So this is the key, country, and names is the value. Key, drive rights, value, key, value. So we know that each of these list of data, when we design or when we make our dictionary, we know that each of these lists will become a column, eventually become a column in our data frame. So that is what we did here. We called names country. We called DR. This just contains truth values, stars and booleans, true or false, true or false. Then these are integers, list of integers. I'm not sure what it means though. So to build our data frame from this data, we simply call PD, which is pandas. Then call the data frame method. Then take Let's call this data instead of dates. Then we take data like data sets. So we pass our data set as an argument in this data frame. And let's see what comes out of this. So this is a data set of cars. If we run this, let's see what comes out of it. Yeah. So we have built our data frame. And like I said, the names become this list of data will become columns in our table. So when we assign this, made this a value of country here, it becomes a column for countries. Then drive rights, this became that for a column for drive rights, and then CPC, which is cars per car, also this column. So this is just another way of defining our data frame. Mr. Kenny showed us how to do it from a file. But this is just, if you know we have a small data set and you just want to do something quick, this is just another way of doing it. So by default, our table, our data frame would come with an index. This column here is called index, and it's generated automatically by pandas library. So automatically it's generated for us, and is an index which are numbers from 0 to 6, or we can say the 1 minus the length of our data, or the length of our data minus 1. So we can decide, oh, this doesn't really make sense to us and we want to give it something else. So then we can come up with another list. Like here, these are short codes for country names. And then, then we take, initially we have defined this data frame as cars. Then we say the cars index and equate it to this list here, 11. We have to make sure that, yeah, this is the same length as our data frame. We have 7 columns of data here. So this also has to be a list of 7 items, and then assign it to the index. When we do that, we print it out. Then also see that, oh, the index has also been changed. So also we can decide to, the same way, when we look at our data and see, these names doesn't really make sense to us, then we can decide to change the column names and say, oh, look at the list of look at the names of the columns, then look for names that best suit what we want, that describes our columns of data. Then you can just say, like we did here, cars.columns, meaning the columns of our data, then we pass a list. So we changed the country column to country names. We change the drive rights to make it look more readable to us. Remove the underscore, make it in caps there. Cars per capita. We also change that too. So then when we do this and check print out our cars, you see, oh, this has also changed our column names. Good, fine. So we also do the same thing here. Also do the same thing. So but here, instead of a list, we passed a single value for our planet's column. And when we do that, passing a single value, it means pandas will simply just assign it and as we just assign the same value to all the rows to match the number of rows in the data frame with the other columns also. So let's look at slicing our data. That's just, say we have a large data set and we want to see, we want to view some columns of that data. Just want to see some particular columns. So what do we do? So we can see we have our cars and we have 3 columns in our cars data set. So we want to remove, we're only interested, say we're only interested in the country and the country, you're only interested in the country names and the drive rights column. So how do we do that? Meaning that we are taking away this column. So you can click simply within the square brackets, then another square brackets again. Then we put the column names we are interested in. And we say we are interested in a country name. Yeah. Paste that. So paste that there. Then followed by common. Then the second column we're interested in, which is drive rights. Paste that there. Then we run this and see what the output will be. So pass. Okay. It's something quickly. Assign this. Okay. This assignment was changed somewhere. So you said we are only interested in the country name, drive rights, and the country name and drive rights. So this is how we get that data we're interested in. Yeah, we see that the cars per capita has been removed from the data frame. So also if we are only interested in say the country name columns, so who can tell us how we get that? Just the country name out of these our cars data frame. Are we here? Mr. Derek, Mr. Olu?
Yes, sir.
Okay. I said we just need to get the country names columns from these our data sets, our data frame. So how do we go about it?
It will be without the parts with the drive rights.
Sorry?
I think it's going to be we just delete the drive rights.
From here, right?
Yes.
Yeah. So that's it, the country names. So another way to, so if you want to let's say we are only interested in some rows of data. Okay. Just like when we are dealing with lists, and we say we are only interested in some number of items on the list. The same way, if we are only interested in some rows of the list, we can slice out those parts. Like just like in a list, we say from the first, which is 0, the first index, which is 0, to the index that we are interested in, say the fourth one. So this is going to print out the first 4 rows of our data sets. This is another way of slicing by row. This will give us the first 4 rows of our data sets. So you can also start from the second one to also give us from the second data set to the third. So from the second row to the third row. This is another way of this one here. This example here will give us, like we said here, from the fourth to the sixth. So from the second to the fourth to the sixth row. So another way of excuse me for a minute. So another way of slicing data frame is the iLog, the lock and the iLog. So to slice columns in panels data frame, where lock is used with column labels or name, and iLog is used with column index and positions. You can also use these operators to select rows from our data frames. So this is what I'm talking about. We have the and the L lock. We so the is used in the iLog is so the lock is used with column names and positions. The iLog is used with in the column names, and the iLog is used with index and positions. So let me bring in an example. This is the format for it. This is to slice a column. You have the start, stop, and the step. So for example, we have the we have our cars dot log, and we want to slice a column. So we can see where do we want to start from. We want to start from I would just want some particular, just want the country names. And then cars per capita. So what does that give us? Yeah. So we've sliced off the drive rights. We have just the country name and the cars per capita. So that's another way of slicing data. Why on this end? This end is meant for index. Say this is for not just for the US. And then AUS. This should give us something. So yeah. Okay. So this is for the US and A. So this is just another way of slicing our data using the log. Like I said, for this we use the label names when we are using log. When we are using this, we use that's the position. So if we want to do the same thing, I think we want to do the same thing with them. So we can save So here, I'm telling you to get from the zeroth row to this should be the second row, but not including that second row. Just like we normally index our list, it's still the same principle that applies here. 0 being the first. And this, since it is less than 5, and this is for the columns, should print out from the first column to the 5th column. But since it is less than 5 columns, it will show us just the 3. So let's make it something. Let's make it something smaller. So to the second column. So I'll run it and see what comes out. So yeah, I've removed the third one. And that's the principle behind the slicing. There are other ways you can expand on this. This is the basic of it. Do you have any question?
No, no question.
Okay. So that should be open to me. Yeah, Mr. Ho.
All right, thank you, guys. Thank you, Mr. Dozier. All right, so we should be clear with all this for now, and this should help us with our other exercise that we're going to take on.